Okay, this is section 2.4. We are applying what we learned yesterday and the day before, applying slope, midpoint, and length formulas. So the first question says, determine the shortest distance from a point to a line. So it gives us the point and it gives us the line. So the point is 3, -1 is here. Now it gives us the line this. Who can tell me how I can graph that line onto this graph? I need to put that line over here. Who can tell me how to do that? Nice. I got a lot of hands here. Nokias, tell me what to do. First place the y coordinate? The y-intercept? Yeah, okay, so what's that? 3. Good. 3, yep. And then? Very good. I love it. Up 2, 1, 2, and then 1 to the right. That is the slope, because we know the slope is rise over run. And we know the rise is 2 and the run is 1. Okay, so we know we can draw it like this. There's another way to do it. Can anyone tell me the other way? Nobody? There's the line. I missed a little bit there. Can anyone tell me the other way to do it? You could have just used the y-intercept method, x and y-intercept. So I would have put in 0 for x, and I would have got y equals 3, which would have been my first point. And the other point, I could have put in 0 for y and solve for x, right? If I did that, I would have got 0 equals 2x plus 3, and then I would have got 2x equals 3, x equals 3 over 2, sorry, negative 3 over 2, which is equal to negative 1.5. So I could have found out that x here is negative 1.5, and I could have joined these 2 points. See how I missed it a little bit? Should be a little steeper. Any questions there? Either way, I could have graphed it. If you can't graph this onto here, well, you're dead in the water. You can't start this problem. So that's why I'm reviewing that. I won't be later on. Write an equation for the perpendicular from the given point to the given line. Now, why the perpendicular? Why does it have to be the perpendicular?
It's the shortest distance.
Right. Good. We learned that from the example we just watched and from me yelling about it. But yeah, we need to get the shortest distance. So we need know the shortest distance is a straight line. Straight line to another line is perpendicular to that. If I went this way, it would be longer. If I went this way, it would be longer. So I have to go at a right angle. So I need to know the equation of this line. Write the equation for the perpendicular from the given point. Okay? Remember, now we are trying to find out the distance of this line. So to find the distance of a line, we need 2 things of that line. Josiah, what are the 2 things we need when we're finding the distance of a line? The endpoints, yes. And we have the first point. It's given to us right here. So we need the other endpoint. That's really what we're looking for. Now, how can we find this endpoint? Jafet, how do you find this endpoint? Because that's what we're trying to find. Douglas? Come on, guys. We just went over all this with the last problem. How do we find this endpoint? What's the plan of attack here? Stefan, you remember? This endpoint. We have this one, we need this one. How do we find this one? Come on, guys. We just went over this. Andrew. Yeah, we're gonna talk about slopes, but what do we need? What is this point called? Yeah. Yeah, it's the PY, right? This is the point of intersection. So we need to find the point of intersection of these 2 lines. Right? And how do we find the point of intersection between 2 lines?
You have to find the equation for both lines.
Yes. You're going to find the equation for both lines. You got to use elimination or substitution, and then you can find it. We don't know the game plan, we can't do the work, okay? So it says here, step 1, write an equation for the perpendicular from the given point to the line. So we need an equation for this line. So we have a point on this line. Do we have the slope of this line, right? Because we can get an equation of the line if we have a slope and a point. Do we have the slope of this line? Yeah.
Negative 1 over 2.
-1/2. Yes, that's correct. Why? How do you know that?
Negative reciprocal.
Good. It's the negative reciprocal of the slope of this line. The slope of this line, we know, is 2. It's given up there. The slope of this line, therefore, has to be -1/2. Okay? So we have the slope. We have a point on this line. We have this point here, 3, -1. That should be enough to allow us to create the equation of that line, right? We know the equation of a line is y equals mx plus b. We will substitute in our slope, which is -1/2 x, plus b. We don't know that yet. Now we're going to sub in point, any point on the line. So we're going to sub in this point. So we have -1 equals -1/2, 3 plus b. b is equal to -1 plus 3 over 2. This is moving over. So we have -2 over 2 plus 1 over 2. This is 1 over 2 equals b. Therefore, our equation of our line is -1/2 x plus 1/2. That's the equation of the perpendicular line. Make sense? Any questions there?
Yes, sir.
Yeah.
How did it go to 1/2 again?
How did it go to?
From -1 plus 3 over 2.
Oh, because 1 plus 1, -1 plus 1.5
Oh,
is -1/2, right? I can do the extra work if you want to see it. Right? Make sense? Okay. Any questions there? That's the first step. We got the equation for the perpendicular. That's done. Yay. It's correct. I checked the solutions. Next, it says, find the coordinates of the point of intersection of the perpendicular and the given line. So, this point, we need to find out. So how do we find out the point of intersection? I know Ethan just told us, but I want, Rudy, tell me again. How do we find out a point of intersection? This is from Unit 1, Rudy, you remember? Point of intersection of two lines, how do we find that out, where they meet? You don't remember? Jaden's going to help you out. Jaden, you remember? What do we need to find? There's a line here and there's a line here. How do we find out where they meet? It's from Unit 1. Josiah, you're going to help Jaden now. We'll go down the line here. Someone's going to get it. Sorry? No. That's the length of a line. We want to know the intersection of a line. We go to Adrian. Intersection of two lines. How do we find it? RC, you're whispering to him. You know it? Y equals mx plus b. That's the equation of a line. How do we find where two lines intersect? I'm 0 for 1, 2, 3, 4, 5. Jafet.
You either eliminate or substitute.
Yes. Yes. You have to find the equation of both lines. You want to find out where they intersect, and then you use substitution or elimination to find out the point. Okay? I'm going slow here, but if you guys, if we don't know that, we can't do any of this work, right? Find the coordinates of the point of intersection. So how do we do that? We need to find out both equations of the line. So the first line was given to us. The second line we found. Right? Those are our two equations. Okay, so now let's continue with substitution because we already have them set up that way. I'm going to substitute this y in for this y and I'll get this. Okay, now if you just want to get rid of the fractions altogether. If you don't like dealing with them, we could multiply everything by 2. Right? Because this is a pretty basic fraction. So we would get 4x plus 6 equals negative x plus 1. Any questions there, what I did?
Sir,
Yep.
it's okay if we just always clear the bracket to make it easier for us.
Clear the fractions? Yeah, I don't care how you get the final answer. You could straight up use your calculator. I'm still going to give you the marks if you know how to use a calculator with fractions. But that's one way to do it. Depending on how the fractions are set up, it may or may not make sense to do it that way. Adrian, you had a question? Sorry?
It's not my favorite.
What?
I have something on.
Okay, no problem. All right, so now I'm going to keep going. I'm going to get 4x plus x equals 1 minus 6, 5x equals negative 5, x equals negative 1. Now what am I going to do with that, Douglas? I got x equals negative 1. That's great. What do I do with that?
You substitute it?
Yes, into which one? 1 or 2?
1.
Yeah, I like it. Why 1?
Because it doesn't have any fractions.
Yep. That's a good enough reason for me. Oh, look how baby these numbers are. Y equals 1 and x equals negative 1. You know you're onto something when the numbers are so simple, right? When everything divides out so nice. So we know our point of intersection then, our POI. Now we could go one step further and we could verify that we did this correctly and plug them back into the other equation and solve and make sure the left side equals the right side. But given the fact that they're negative 1 and 1, we're probably in a pretty good state. So the point of intersection we know is negative 1, 1. Now we can also check the graph and see if that makes sense. Negative 1, 1. Does that look about right? And we remember that I missed a little bit on my line. So yeah, it's right there. So that does work. So if you were doing Lucas's shortcut, you could just go right from here down to here, right? Wouldn't that be nice? You could just read the graph. All right, use the distance formula. Now that's the final step. So we have our point of intersection. We have our equation of both lines. Use the distance formula. What 2 points am I going to use on this distance formula? Or sorry, what is the distance formula? Because you need to know what this is too. Max, do you remember it? You want to try it? No? You weren't here yesterday. Okay, Andrew's going to tell us. What is the distance formula? We're going to call it A and S for Andrew.
So the distance formula.
The distance of AS is, yeah?
Is equals to what's that?
Square root.
Yeah, square root.
Just give it to me without the numbers first.
Uh,
X.
1 minus x2 minus x1. To the power 2 plus y2 minus y1. To the power 2.
Yeah, you got it. So now the 2 points we're going to use is the 2 points on the line, which Josiah has told us, the end point. So we're going to use 3, negative 1 and negative 1, 1, right? These are the 2 points we're going to use. So 3, negative 1 and negative 1, 1. Those are my 2 points. Okay? So I can do x2 here, negative 1 minus 3 squared plus 1 minus 1 squared. Now again, it doesn't matter the order if I went x2 minus x1 or x1 minus x2 because I'm squaring it, so it won't matter. So I don't actually know which one I used here first. So now this becomes negative 1 minus 3, so it's negative 4 squared plus negative 1 plus 1 is 2, so it becomes 4 squared. This becomes 16 plus 16, square root of 32. And I made a mistake. 1 plus 1 is not 4, it's 2. My bad. Ethan, what's going on, man? I'm gonna keep blaming Ethan when I make mistakes for not checking. So that's our exact solution, root 20. Now we could do that on our calculators and we would get, what would we get here? Root 20. We would get 4.472. Now if I wanted to round this to 1 decimal place, what would this be equal to? Teori. 1 decimal. So I'm looking at the 1 decimal. I got to decide if that goes up or stays the same. Good. That would be your approximate answer. All right? Any questions? Example 2. Determine a geometric property algebraically. So the vertices of triangle ABC are ABC. Determine whether ABC is a right triangle. Oh boy, this is going to be some work. So let's find out. A, we're going to plot 5, 5. There's my A. B is going to be -3, -1. C is going to be 1, -3. Now I'm going to join them. All right, there's my triangle. Method 1, we're going to use slopes to determine whether ABC is a right angle triangle. So, what 2 lines do you think I should check the slope on? AB, BC, CA, Max's. AC and what? I said, what 2 lines should I check their slope?
I think AC and CD
And what?
and like DC.
Did you say DC?
BC, like
Oh, BC, yeah. This line and this line. Why'd you pick those 2 lines?
well, that's because that's where the right angle sits in that corner. You see is
Yeah. And that's just based on observation, right? Maxis sees that this is clearly not a right angle. This is clearly not a right angle. So if we want to know if this is a right angle triangle, we want to check this angle here. Does that make sense? Now, if you don't do that bit of investigation first, you're going to waste a lot of time. You're going to be checking slopes that are clearly not perpendicular. Now, how can we check if these 2 slopes are perpendicular? How can we check? Besides Ethan. Anyone else? This is pretty easy, right? We've talked about this. Max, you remember? When 2 lines are perpendicular, what do we know about their slopes?
The other side is like negative. I forgot the word.
Yeah, the negative, it's called reciprocal.
Yeah.
But like the flipped, right?
Yeah.
Flip it and make it negative. That's called negative reciprocal. All right? So if this slope is the negative reciprocal of this slope, then we know that this is a right angle. Make sense? I hope. So we need to check both the slopes. So we'll check M. We're going to do little m of AC. That's our first one. So AC, our points are this and this. So we need to calculate the slope. So it's y2 minus y1 over x2 minus x1. Now here it's more important that we know which points we're picking, right? Because there is purpose behind the order. It doesn't get squared, so it will matter. So y2 is, we got to make sure it's the second point here, 5 minus y1 is this point here, -3. And then we have x2, 5, minus 1. 8 over 4, which is 2. Beautiful. So what do I want my slope of BC to be in order to know it's perpendicular? RC? Nope. Sorry? I don't want it to be 2. I already have 2. I want it to be the negative reciprocal. So what's the negative reciprocal of 2? Nope. Negative 2 would be the negative of 2. Yeah. No. Oh man, come on. Guys, 2 is the same as 2 over 1. What's the negative reciprocal? Yeah.
Is it negative 1 over 2?
Yes. Negative 1 over 2. That's what we want. Okay, so let's check now. We're doing BC, right? So we're going to do the same formula. y2 is negative 3. Minus y1 is negative 1 over x2 is 1 minus negative 3. Negative 3 plus 1 is negative 2. Let's see if I can not mess up on the simple math. 1 plus 3 is 4. So we get negative 1/2. Booyah! Are they negative reciprocals? Yes. So we're going to say, I don't know if you know this triangle. You guys are used to this triangle, right? I know somebody in this class loves the 3 dots as therefore, because it's a shortcut for therefore. Anybody know what these dots mean? What?
It's upside down.
Do you guys know what the 3 dots mean therefore?
Yeah.
You never knew that, Maxis?
I don't know what 3 dots mean.
No? So these 3 dots, here, I'm going to put a little note here so you guys have a shortcut for this. This means therefore. And it's a shortcut when you're doing word problems to write those 3 dots. These 3 dots means since. So if you have an upside down triangle. So what I would write here then,
That in my essay,
what?
so I should put that in.
Yeah, maybe. You could write since MAC is perpendicular to MBC, therefore the triangle is a right angle triangle.
No, that's in my brain.
It's hurting?
That's in my brain. It's too much.
Too many symbols?
It's an upside down T.
That's perpendicular. Perpendicular. Right? I do that sometimes when you're doing slope. You want to say the perpendicular slope.
So isn't it perpendicular or right angle?
Same thing.
Same thing. Yeah. You're right. It gets confusing, I guess, with the symbols. Oh, that's my conclusion, by the way. That goes down there. All right. Next method. Use the Pythagorean theorem. So how could we use the Pythagorean theorem to discover if this is a right angle triangle? How would we do that? Anybody want to take a risk here? Tell me what to do. Can't do this all on my own. First of all, it might be a good idea to know what the Pythagorean theorem is. What is it? Yeah, Lucas? A squared, what? Okay, equals c squared. Right. And so in this case, where's A, B, and C? Maxis, where's A?
Sorry?
Where's side A? Where's side B? And where's side C in this triangle?
It's at the top.
A's at the bottom? Sure, that works. You could do A for either, right? B would be here, right? And C would be here.
Oh, okay, my bad. I'm listening.
Does that make sense, guys? C is the hypotenuse, right? C is the only one that really matters for this formula. Okay, so what we need to find out then is, using the Pythagorean theorem, we actually need to find out what the distance of this line is, what the distance of this line is, square them, and add them together, and see if it's the same as the distance of this line squared. Ooh, It's a lot of work.
So is this just another method to, or another way of finding? the
Yep.
variable?
Yep.
So we could just use the slope one.
Well, not if I tell you to use the Pythagorean theorem, you'd have to use that as well. But it's basically a test of you figuring out the distance of lines, right? Just with a purpose now. You're doing it 3 times, right? Okay, so another way to write this, we could say that AB, well, let's just leave it as A, B, C. I've labeled them A, B, and C here. Okay. So let's find out the distance of AB first. Let's do the hypotenuse. So let's find out C. So let's go length of C squared. Okay. How do we find out the length of a line if we have the 2 endpoints? Who wants to give it to me? Oh, sorry. Who wants to give it to me? The length of a line, the formula? Adrian? Square root?
Oh, square root in brackets x2 minus x1 to the power 2 plus y2 minus y1 to the power 2.
Okay. And the 2 points here we're going to use for C, for length C here, I'm going to get them from my triangle. Okay. My point 1 is going to be -3, -1, and my point 2 is going to be 5, 5. So I'm going to sub these into here. Oh. Yeah.
So I got kind of confused with this even like last night for the homework, but right, the second set of equations where it goes 5 take away -3 squared. Wouldn't x2 be from B and wouldn't x1 be from A?
Say that again?
Wouldn't x2 be from like B and wouldn't x1 be from A? You say you did like 5 take away -3, but the 5 is from A.
The 5 is from A, yeah. We're doing this point minus this point, right?
Oh, okay.
So this point is 5, 5. That's x2, y2, and this point is -3, -1.
But I'm saying like, how do we identify like what's x2 and what's x1?
Oh, usually the first one is on the left.
Oh, okay. I was
It's
going
always
off,
read from left to right.
I was going off like alphabetical order last night, so I got some of them wrong.
No, because these letters are just arbitrary. I just picked them.
So it's left to right?
Yeah, this could be like a J or an X or a K or a Y. It's always left to right. It's the same as slope. Okay? Slope is more important, right? Because slope you have to have the order right. So the first point, it's a great question. Because if you don't remember that, how do you know what is x1, y1? It's the one on the left. Okay? Okay, so there's our length of C squared is 10. Okay? The next thing we're going to do is we're going to find the length of A now, which is here. This is A. So we're going to use the 2 points B. So I'm going to start on the left side. I'm going to use, so let's go length. See if I can try and fit this in. Length of A. Okay, so this line here. So my 2 points are going to be -3, -1, and 1, -3. Those are the 2 points because they're here. Okay. Now I'm going to say A is equal to the square root x2 here. Negative 3 plus 1. Okay, any questions there? Finally, we have enough space. We're going to find the length of B. Okay, B is over here, so my 2 points are going to be 1, negative 3, and 5, 5. Okay, this point and this point, that's B. Right? All right. So, I got my 3 lengths. Now, what do I need to determine if this is a Pythagorean? Sorry, if this is a right angle triangle? Who can remind me? I have my A, B, and C. What do I need to determine? Did you? No, not the slope. Well, yeah, which line is the longest would be a good start. We know which line is the longest because we can see that this is the longest. It's the hypotenuse. But how do I determine if this is a right angle triangle with these 3 lengths? Yeah.
You have to do C squared equals A squared plus B squared, or the other way around.
Yeah, you're exactly right. Thank you, Andrew. It'd be great to do all this work and then not know what to do. That would suck. So we're going to check now. This is C, right? This is the length of C. So C was 10, so we're going to do 10 squared is equal to A is root 20 squared plus B is root 80 squared. So 10 squared is 100. Root 20 squared is